Hey guys, welcome back to WD Explains. I'm Wilson, and today we're going to be talking about balancing chemical equations. So, why do we balance? Well, because of the law of conservation of mass. Atoms aren't created or destroyed in a chemical reaction, so the numbers have to equal on both sides, so we're not creating or destroying atoms. Every atom that goes in must come out. So in this example here, iron oxide plus sulfur gives us iron sulfide plus oxygen. In this case here, we're destroying oxygen atoms and we're also destroying sulfur atoms. So this equation as it is doesn't work, it doesn't make sense, it's illogical. So some things that you must know before we get started is how to use the least common multiple. You have to know your elements, like your basic elements, what an element is and all that sort of things. And then also the basics of writing compounds and elements. So the basics. Here we have the synthesis of water reactions. So we have hydrogen and oxygen giving us water. So the basics here to start are counting up what you have. So I like to draw a line on that. We have our hydrogen, we have our oxygen, and over here we also have our hydrogen and oxygen. So over here we can see we have 2. Over here we see we can have 2 oxygen. Over here we have 2 hydrogen. But over here there's an imaginary 1 there. We only have 1 oxygen. So something's not right here, so we need to balance. So here's how we would balance this. So first of all, we'll draw our chart again. HO, HO. So we have 2, 2, 2, 1. So the first thing we'll do here we're going to put a 2 in front of our water on this side. So then we'll do our revised chart here. 2, 2, 4, 2 of HO, HO. So now our oxygen is good, but now our hydrogen has been thrown off. So we're going to throw a 2 in here, and then this is going to make this 4, 2 for HO, HO, and this is going to be 4, 2. So we have 2 times 2 here for 4, and 2 times 1 here for 2, 2 times 2 over here for 4, and then 1 times 2 here for 2, and they equal. So then we've just balanced this equation. So here are just some quick tips for balancing. We just balance one element at a time. So when we're looking at this, we're not looking at both hydrogen and oxygen at once. That's how we get confused. We take it one step at a time and we balance it one step at a time. Tip number 2, we start with our least involved elements. So in here we have quite a few things going on. This is a combustion reaction. As we can see, oxygen is in 3 places. So if you start with oxygen, you're just going to be bouncing all over the place and you're not going to get anywhere. But if you're going to start with hydrogen or carbon, it's going to be simpler because they're in less compounds. Each of them is only in one compound on each side, so it's going to be easy. It's not like it's in 2 compounds and you're just going to be banging your head off a wall. So tip number 3 is to use a chart, like I was saying earlier. So we have our FeHCl, FeHCl. This is just imperative to keep your information organized so you can do the question properly. If you're not using a chart, I think it's really kind of stupid if you just want to keep track of anything in your head. If it works for you, fine. But I think this would work for a lot more people, is keeping track of everything. And I think it just makes everything much easier. We won't balance that one. I think we do later. But that's just some tips for how you balance. So we'll just balance this simple combustion reaction. So we're oxidizing iron to make iron oxide. So we'll start with our chart. We have our iron, and we have our oxygen. We have iron, and we have oxygen. So we have 1 iron, 1 oxygen. We have 2 iron and 3 oxygen on this side. So this is a pretty simple fix. We're going to multiply our iron by 2. And we're going to stay doing it 1 element at a time. Now as you get better at balancing, maybe you don't need to do it 1 element at a time, but if you're just starting off, you definitely want to. So we have 2 iron now, 1 oxygen. We have 2 iron over here and 3 oxygen. So over here on the left, now, because we've moved on to oxygen because we've solved iron, we're going to add 3 in front of that oxygen. So now we can redraw our chart. We have 2 iron, 3 oxygen. And on this side, we have 2 iron, 3 oxygen. So all is well. We've balanced this equation. I'm going to let you guys pause the video and try this one first to see if you can balance it. So remember the tips we went over from the last slide, or last couple slides. Okay, so we're going to balance this one together. This was like one of our examples, so I'm going to choose to solve this starting with carbon, but we'll draw our chart first. So we have C, H, and O, C, H, O. We have 3 of these, 8 of these, and 2 of these. We have 1, 2, and 3. So it's all over the place, totally unbalanced. So the first thing I'm going to do, I want to change both of these to the same. So I'm going to start by putting a 3 in front of the carbon dioxide. So we have C3H8 plus O2, 3CO2 plus H2O. Now I'm going to skip using a chart in this step because we've only changed one thing. But I know we have 3 carbons. Well, we'll draw a chart again to keep things consistent. We won't draw in the letters again. So we have 3, 8, 2. And here we have 3, 2, and now we have 7 oxygens. So things aren't, we've solved one, but we've changed another one. So we have the carbon solved. So now we have to go to our water to fix the hydrogen. So we have 8 on the left and we have 2 on the right. So we're going to put a 4 in front of the water. So we have C3H8 plus O2, 3CO2 plus 4H2O. A little cramps there. So we have 3 carbon, 8 hydrogen, 2 oxygen. Now we have 3 carbon, 10 oxygen, or 8 hydrogen, and 10 oxygen. So the first 2 numbers are good. And now we're just going to put a 5 in here to multiply this by 5 to get 10. So we're going to have C3H8 plus 5O2, 3CO2 plus 4H2O. Little divider there. So we'll do our chart again to make sure everything's good. We have 3 carbons, 8 hydrogens, and 10 oxygens. Over here we have 3 carbons. We have 6 oxygens here, 4 oxygens here. That makes 10. And then we have 8 hydrogens here, which makes 8, and it's equal. So that is balanced now. Okay, we're going to balance this one now. I'm going to let you guys pause and try this first. Okay, so we're going to write our chart here. We have aluminum, hydrogen, and chlorine. We have aluminum, hydrogen, and chlorine. We have 1, 1, and 1. And here we have 1, 2, and 3. So we'll start with chlorine here. So we have 3 over here and 1 over here. So first thing I'm going to try is adding a 3. So we have aluminum plus 3HCl, AlCl3 plus H2. So I'm going to draw my chart here. So I have 1 aluminum still. Now I have 3 hydrogen and 3 chlorine. And over here I have 1 aluminum. Now I have 2 hydrogen and 3 chlorine. Okay, so we have a 2 and a 3 here. So this is where we're gonna have to use our least common multiple. So we're gonna have to multiply the hydrogen on this side by 3, and we're gonna have to multiply the hydrochloric acid over here by 2. So it's gonna equal 6 in both cases. The number of hydrogens we're gonna have is gonna equal 6. So we're gonna have aluminum plus 6HCl, and that's going to give us AlCl3 plus 3H2. And this gives us now 6 hydrogens on both sides. So now we do our chart. We have 1 aluminum, 6 hydrogen, 6 chlorine, 1 aluminum, 6 hydrogen, and 3 chlorine. Okay, so we have to worry about aluminum and chloride now. So what we're going to do is, the only thing we can do here, we have 3 and 6. We can't get rid of the 6's, so we're going to have to multiply the chlorine on the right side by 2. And this is going to give us what we need. This is going to give us 6 chlorines on both sides. So we're going to have aluminum plus 6 HCl gives us 2 AlCl3 plus 3 H2. We'll do our chart. So gives us 1 aluminum, 6 hydrogen, 6 chloride. Ignore that. And then over here we have 2 aluminum, 6 hydrogen, and 6 chloride. So still not balanced. We have one thing left to do. And as you might have guessed already, we're just going to put a 2 in front of this aluminum, and this is going to change this to a 2. So our full balanced equation is 2 aluminum plus 6 HCl. It's going to give us 2 aluminum chloride plus 3 hydrogen. And now our equation is balanced. You always want to do a final check, even though it was long and you want to be over with. And we'll do a full chart here with our letters. AlHCl. We have 2 aluminums right here. We have 6 hydrogens. We have 6 chlorines. Here we have 2 aluminums. We have 6 hydrogens, and we have 6 chlorines. So as we can see, we balance them. Yeah, so we've balanced this equation, and that's the end of this question. I hope you guys learned something, and that's the end of this video. Thanks.